Assalamu alaikum students. This is your third lecture of water supply and sanitary engineering. In this lecture, you will study about the pH value, alkalinity. As explained in the previous lectures, these are the chemical characteristics of water that affect its chemical properties. Starting with the pH value. As you know, pH is the negative logarithm of hydrogen ion concentration. The pH value of water gives its acidity or alkalinity. That is how much acidic or alkaline the water sample is. As more acidic or more alkaline water may not be fit for consumption. The water, as you know, consists of hydrogen ion and hydroxyl ion. If the concentration of hydrogen ions, that is H positive ions, is more, the water is acidic. And if the concentration of OH negative ions, that is hydroxyl ions, is more, the water is alkaline. For neutral water, H positive concentration is equal to OH negative concentration. Also, the product of H positive concentration and OH negative concentration is constant. Now, the pH of water. If the pH is equal to 7, water is neutral. But if it is greater than 7, water is alkaline. And if the pH is less than 7, water is acidic. The alkalinity of water increases from pH 7 to pH 14, and the acidity of water increases from pH 7 to pH 0. The acidity is caused by the presence of mineral acids, carbon dioxide, sulfates of iron, and aluminum, etc. And the alkalinity it's caused by bicarbonates of calcium and magnesium. The pH value of water is measured by two methods: calorimetric method and electrometric method. In electrometric method, we measure the pH value of water by means of potentiometer. In potentiometer, what is done? The electrical potential of water sample is measured, which gives the concentration of hydrogen ions. In electrometric method, the pH is measured by the electrical potential exerted by hydrogen ion, by which we can find the concentration of hydrogen ions. That is how much hydrogen ions are present in water. That ultimately gives the pH value of water. In colorimetric method, the chemical indicators are added to water and the color is produced. This color is compared with the standard colors of known pH. A large number of indicators can be used, for example, methyl orange, methyl red, phenol red, thymol blue, phenolphthalein red, etc. We can also use glass color discs instead of standard color tubes for comparison of colors. For drinking water, the pH value should be between 7 and 8.5, but the water having pH less than 6.5 or greater than 9.2 is not suitable. So the pH value of water sample should be optimum. If the pH is low, the water causes corrosion of pipes, and if pH is high, it may cause sediment deposition on the pipelines. Now coming on to the hardness of water. What is hardness? You may be knowing that hardness is that characteristic of water which prevents formation of lather with soap, or we can say it is the soap destroying capacity. Hence hardness, it's not a favorable characteristic. The hardness is caused by the presence of carbonates, bicarbonates, sulfates, chlorides, and nitrates of calcium and magnesium. The hardness has mainly two types. One is called permanent hardness and the other is temporary hardness. The temporary hardness is also called carbonate hardness. As the name suggests, it is temporary. means it can be easily removed by boiling or by adding lime. How is carbonate hardness caused? It's caused by bicarbonates of calcium and magnesium. Now, the second type is permanent hardness, also called non-carbonate hardness. It's caused by the presence of sulfates, chlorides, and nitrates of calcium and magnesium. Now, it's not removed by boiling or by adding lime. It requires a special treatment. Now, the total hardness, it's equal to carbonate hardness and non-carbonate hardness. Now, how is the alkalinity and hardness related? The alkalinity in water is caused by the presence of carbonates and bicarbonates. If the total hardness is greater than total alkalinity, then carbonate hardness is equal to alkalinity. And non-carbonate hardness is equal to difference of total hardness and carbonate hardness. Or we can say the non-carbonate hardness, it's equal to total hardness minus alkalinity, because alkalinity is equal to carbonate hardness. Now, if the total hardness is less than or equal to alkalinity, then carbonate hardness is equal to total hardness, and non-carbonate hardness in water would be equal to 0. The hardness is expressed as parts per million or milligram per liter. Now, different levels of hardness are shown in the table. Like, for example, if the hardness is 0 to 50 milligrams per liter, the water is said to be soft. And if the hardness is equal to 50 to 100 milligram per liter, water is moderately soft. If it is 100 to 150 mg per liter, water is slightly hard. If it is 150 to 250 mg per liter, it's moderately hard. And if the hardness of water is greater than 250, the water is said to be hard. Now, the measurement of hardness. How is hardness of water measured? There are two methods to measure the hardness of water. First is soap solution test and the second one is EDTA method. In soap solution test, the soap solution is added to water sample and then you have to shake it for 5 minutes or more than that. The lather formed by shaking the soap solution with water sample is observed. Then compare this lather formed with the lather factor. Now, what is lather factor? It is the lather formed by standard soap solution added to distilled water of zero hardness. We take a distilled water of zero hardness and add the standard soap solution to it. Then the lather formed by this is called lather factor. The difference gives the hardness. In EDTA method, the water sample is titrated against the EDTA, that is ethylene diamine tetraacetic acid. In this titration, EBT, that is Erichrome black tea, is used as an indicator. The total hardness in terms of milligram per liter is equal to volume of EDTA used in ml divided by volume of water sample in ml into 1000. Now, how is hardness measured in terms of calcium carbonate? Hardness as CaCO3, that is calcium carbonate, is equal to M2 positive into equivalent weight of calcium carbonate divided by equivalent weight of M2 positive. Now, M2 positive, it can be any ion, for example, calcium 2 positive, magnesium 2 positive, strontium 2 positive. What are the effects of hardness? The excess hardness is undesirable. As more soap is consumed, it affects the dyeing work, scaling of boilers take place, corrosion of pipelines, and it makes food tasteless. For drinking water, hardness should be less than 200 mg per liter. But if it is greater than 600 mg per liter, the water should be rejected for use. Now coming on to the alkalinity. It is the capacity to neutralize the standard solution of acid. It is due to the presence of bicarbonates, carbonates, and hydroxides. Maximum alkalinity is caused due to bicarbonates. The bicarbonate alkalinity and hydroxide alkalinity are never present in the same water sample. So the total alkalinity can be either equal to carbonate alkalinity and bicarbonate alkalinity or carbonate and hydroxide alkalinity. Now if we consider the pH value of water, the alkalinity has two parts: total alkalinity and caustic alkalinity. The alkalinity is called total alkalinity if the pH value of water is greater than 4.5, and it is caustic alkalinity if the pH value of water is greater than 8.2. The alkalinity is determined by titrating a water sample against a standard solution, that is N by 50 or N by 40 of sulfuric acid. And the indicators used in this titration are phenolphthalein and methyl orange. Alkalinity is also measured as carbonate and bicarbonate alkalinity, where the total alkalinity as carbonate is equal to carbonate alkalinity into zero point 0.6, and the total alkalinity as HCO3 is equal to bicarbonate alkalinity into 1.22. This was the end of this lecture. In the next lecture, inshallah, we will study about the numerical type questions regarding pH, value, and alkalinity. Thank you.